Okay, I'm going to work these position time equation questions that he posted. Here's your formula, xf equals xi plus vit plus 1/2 at squared. Just know that this is the final position, that's going to be meters. This is the initial position, meters. This is the initial velocity, meters per second. This is time, seconds. This is acceleration, meters per second squared, and time, seconds. All right, so looking at our question number 1, a car is driving past at 10 meters per second. So that's its initial velocity, 10 meters per second. When the driver steps on the gas, accelerating at, so he steps on the gas, so that's going to be a positive acceleration, 5 meters per second squared. So I'm going to put that for A. For 5 seconds, that's going to be the time. All right, how far will the car move during that time? So we want to know his final position. We're going to say his initial position is 0 just to keep it easy. We'll say that's a good starting point would be 0. This we don't need to know. That's not in the formula. Okay, so we're going to do xf equals xi plus vit plus 1/2 at squared. xf we don't know. This whole section right here is 0, so I'm not even going to put that. Equals vi is 10, time is 5, plus 1/2 5 meters per second squared for 5 seconds, and then in the formula we square it. So xf is going to be, I'm going to put that in my calculator, 10 times 5 plus 1/2, I just put 0.5 in my calculator, times 5 times 5 again, and close my parentheses and square it. I get 112.5. 112.5 meters. That's going to be xf. Then he wants to know how fast the car will be going after 5 seconds. How fast is going to be vf. So I'm going to use vf equals vi plus at. vf I don't know. vi is 10 plus a is 5, t is 5. vf equals, so I'm going to do 10 plus 5 times 5 to get 35 meters per second. Okay, so there's an example for that one. So even though this is the only formula he posted here, that doesn't mean you can't use your other formulas that we've been learning in class. All right, so looking at number 2, a bobsled starts from rest. Okay, so its initial velocity is 0, moves down a hill accelerating at 2.5 meters per second squared, so that's going to be A. That's 2.5 for 8 seconds. How far is the position will the sled travel in that time? So again, I'm going to label his initial position as 0 just to make it easy. We want to know his final position, and he probably wanted us to solve for that too, so we'll solve for both of them. All right, so we're going to say xf equals, I'm not even going to put xi because that's 0, so I'm just going to go straight to the vit plus 1/2 at squared. xf, I want to know. vi is 0, so anything 0 times 8, 0 times the time is going to be 0 as well, so that's good. Plus 1/2 a is 2.5, t is 8 squared. So this whole section right here, that first part of that formula, you can kind of X out because that's going to be 0. So xf equals 1/2 2.5 times 8 squared. When I put that in my calculator, I'm going to do 0.5 for 1/2 times 2.5 times 8 squared, and I get 80. So xf is equal to 80 meters. And then if he wanted to know, he didn't ask this, but if he wanted to know VF, you would just say VF equals VI plus AT. VF equals VI is 0, so I'm not even going to put that. A is 2.5 and T is 8. So 2.5 times 8 is 20. VF equals 20 meters per second. Okay. Number 3 says a car is driving at 35 meters per second. So that's going to be the initial velocity when the driver, I think that's supposed to say hits the brakes, hits the brakes, giving the car an acceleration of negative 2.5. So we're going in the opposite direction for acceleration because we're technically decelerating for 3 seconds. How far will the car travel during braking time? So I want to know its final position after it brakes. I'm going to say the initial velocity was 35 meters per second, and I'm going to give him the initial position of 0 meters just to make it easy on myself. How far? Okay, so XF equals VIT plus 1/2 AT squared. And again, I'm going to leave out that part of the formula because that's 0. XF equals VI is 35. T is 3 plus 1/2. Don't forget the negative. Negative 2 is your acceleration. 3 seconds and squared. All right, so that's a 35. So I'm going to say 35 times 3 plus 0.5 times negative 2 times 3 all squared is 96. So XF equals 96 meters. And then it says how fast, so I'm going to say VF equals VI plus AT. How fast, I don't know. His initial speed was 35 plus negative 2 times 3. So 35 plus negative 2 times 3 is 29. So his final velocity is 29 meters per second. All right, then you have this one. A ball is rolling at 2 meters per second when it begins. All right, so it's initially rolling at 2 meters per second. Begins rolling down a hill, accelerating at 3 meters per second squared. That's the acceleration. How far will the ball travel in, so I want to know final position in 4 seconds of time. So again, his initial position, I'm going to put as 0 to make it easy. And I don't know, I'm going to use the VF part for how fast in a second. So XF equals VIT plus 1/2 AT squared. XF equals VI is 2, time is 4 plus 1/2, 3, 4 squared. Okay, so 2 times 4 plus 0.5 times 3 times 4 squared is 32. So XF equals 32 meters. How fast? So we want to do VF equals VI plus AT. VF equals the initial velocity of 2. The A is 3. The time is 4. 2 plus 3 times 4 is 14. So it's going to be traveling at 14 meters per second at the end. All right, and then a sprinter starts at rest. All right, so starts at rest. So VI is 0, so that's great. Makes it easy on us. He accelerates from 3 meters per second squared for the time of 2.25 seconds. How far will she travel? All right, so we want to know XF. This is 0. This we don't know. Okay, so XF equals VIT plus 1/2 AT squared. XF, I want to know. VI is 0, so I can leave that whole portion out because anything times 0 is 0. So I'm going to go straight to 1/2 times 3 is A. T is 2.25 squared. So when I do that, 0.5 times 3 times 2.25 squared is XF equals 7.59. I'm going to round up to 7.6 meters. The end.